In the last lesson, we were comparing series and parallel circuits. I just want to remind you of some of the things that we said last time. First of all, we said that the series, you're only going to see one pathway for the electricity to follow. So if it comes from the battery, it's going to follow along and there's no other place for it to go. However, in a parallel circuit, you're going to have it leave the battery and be able to take this route or go past that junction and come to this branch over here. Okay? That's going to affect the way that voltage and current are shared between the pathways. If you're looking at this series circuit right here, the voltage coming out of the battery, remember that voltage is potential difference, which is the push power of those electrons. With the push power from the battery, the electrical potential difference is 12 volts, but that's going to be shared between both of these loads, these two light bulbs. So you can see then that the V total coming out of the battery, or the V of the source, is equal to the voltage of the first load plus the voltage of the second load. So 6 plus 6 tells me that's a 12-volt battery. Or I can work backwards and I can say I know it's a 12-volt battery and I know that there's two loads, so I can divide between them. Now keep in mind, this means that we have identical light bulbs. If I had a different type of light bulb in here, it may have a different voltage requirement. Let's say I inserted another light bulb. It's still a 12-volt battery, but this new light bulb only requires 4 volts. That means there would be 8 volts for the second one. Okay, so keep in mind that when we're doing some of these assumptions, we're saying that these lights are exactly the same quality of light bulb, using the exact same amount of power and voltage and current. Okay? So when you are dealing with a parallel circuit now, you have equal voltage in each of the branches, because this branch here, this one circuit, has its own access straight to the battery, so it's got full push power going through there. And then this circuit also has full push power, or full voltage, flowing through it. So you'll actually see that in a parallel circuit, the voltage total is equal to each of the branches. So each load gets full voltage. Okay. Now that is going to have an effect on the brightness of our bulbs. Let's look at these examples here. If I have 12 volts, let's say now I have 3 loads or light bulbs placed in series. The voltage now we know will be shared between all of them. This will be a lot dimmer, as 4 volts will be much dimmer than it would be if there was only 1 volt who got the complete 12 volts. The voltage really tells you how bright that light bulb is going to be. Now when we have the separate branches here on this parallel circuit, the first 2 branches have their own equal access for each of these loads to the 12-volt battery. So this is going to be a nice bright bulb. This one will be a very nice bright bulb as well. But I created a combination circuit here. So in the last pathway to the battery, we're going to have 2 light bulbs placed here. And that is going to mean they have to share the voltage. Again, assuming that they are the same type of light bulb, we're going to split it even, 6 and 6. These two light bulbs with their only 6 volts each will be much dimmer than the 12-volt bulb that we see over here. Okay? So the first 2 will be equally bright, and these ones will be dim compared to these 2. Equal to each other, but dim compared to these 2. Okay? When we look at the current between them, in a series circuit, the current is the same at every point. So it doesn't matter whether you test right next to the battery on the way back in, test the battery here, in between the light bulbs, doesn't matter where you test, you're going to see that if it's 3 amps flowing through this section here, it'll be 3 amps everywhere in that one branch of the circuit. They'll all be identical. That's because current represents the number of electrons flowing past a point. And because the electrons have nowhere else to go than this one pathway, all the electrons will travel down the same pathway. So at any point, you'll get full electron flow. Over here, though, we've got 3 separate branches. So now we see that when the current that is flowing through the main branch that everybody is connected to may be full, 3 amps, but when it comes through this branch and this branch and this branch, the current gets split between them. And again, I show you a graphic of that in your last note if you want to take a look back at that. Okay, but when they begin to collect again, because again, this is a shared pathway for all 3 sections, I'll get the full value of all the current flowing through here. So coming straight out of the battery and coming straight back into the battery, I'll have full value. It's only in the branches that I'll see a different amount of current because it's being shared between all 3 branches. Okay, so that's the stuff we talked about last day. And I introduced the idea of ammeters and voltmeters, but now I want to show you in detail how to add them to a circuit. Doesn't matter what type of circuit you have, whether it's a series circuit, a parallel circuit, or a combination circuit, whenever you're using a voltmeter, add it in parallel. That means it's going to have its own pathway, and you're going to test on either side of whatever you want to test. So what we're really doing then is measuring the difference between 2 points, because voltage is potential difference. It's what's the push power on this side of the load versus the push power on the other side of the load. We're trying to get the difference between those 2 points. So it doesn't matter whether you're doing a series circuit or whether you're doing a parallel circuit, you always add them in parallel if you're doing a voltmeter check. Okay. Now here again we have a series with more than one. And again we've got the voltmeter added in parallel for each of these. And notice again we got 9 volts being shared between 3 light bulbs, so they should have a reading of 3 volts each. Shared voltage in the shared path. Okay. And now we've got a parallel circuit, and we're going to have its own pathway and its own pathway, equal access to the battery. When you test them, you will see that they will have equal compared to what the battery is providing, equal push power pushing through there. Okay, so equal voltage per path. When you're adding an ammeter, it has to be in series because I want to check the flow of the current through this particular area. So it has to flow through the meter. Okay, it's going to be important that when you hook up positive end, so the positive end here, notice it's attached to the positive side, and the negative end of the meter is attached to the negative end of the circuit. Okay, so negative to negative, positive to positive, and you'll get your flow running through. Just a reminder that this is a symbol for any load. This is a symbol for a resistor. So really any load should be resisting the circuit, so we can just from now on just use this symbol as saying the load or the resistor. Okay, and remember you can put the ammeter anywhere within the unique path to measure that load. I could place it here, I could place it on the other side, I could place it on this corner. It doesn't matter because the current will be the same anywhere in that pathway. If I have a parallel circuit, then I can have 2 pathways here. So you've got the little red pathway, and then we have the big green pathway flowing around the outside. If I place it in this pathway here, A1, well, this is the common pathway for both of these branches. So this should measure both loads. A2, though, is in a unique pathway. So is A3. So A2 and A3 will only measure the current that's flowing through load 2. A4 is also in this unique pathway that is not shared by load 2. So A4 is where you want to place it if you only want to measure load 1. You could also do it on this side of the resistor as long as it's not in the shared pathway. When you get back to A5 and A6, again, this is a shared pathway for both load 1 and load 2, so it will measure both loads. You're going to be asked to be doing some simple calculations. So here's an example of what you might see. You might be given a diagram like this and given some of the information, but not all of the information. So you're going to be asked to find the voltage across load 2, which is right here in this particular case, and the current through ammeter 2, which is over here. Okay. Now, here's the key fact. This is a series circuit. You can see that it's got one pathway for the electrons traveling through both loads. All right. You've been given the voltage of the source, and you've been given the voltage across load 1. You're just asked to find the voltage here. Well, the voltage of the source, remember that the upside down 3 dots means since, so this says since the voltage of the source is equal to V1 plus V2, so both of those voltages together, then V2 should be equal to the total voltage, the voltage of the source, minus the voltage being used by load 1. So the voltage of the source minus the voltage being used by load 1 should give me this. Well, if it's 12 volts here, and I've only used 4 volts here, I should have 8 volts left, and that's what you see in this answer right here. And then, because I'm using a series circuit, we have shared voltage but equal current anywhere in the circuit. If this one here, and notice that I is the symbol, capital I is the symbol we're going to be using for current. If the current is equal to 2 amps here, it should be equal to 2 amps everywhere in the series circuit. So A1 should be equal to A2. Therefore, 2 amps is equal to that A2. All right? There's no branches. I is the same everywhere. Another example here. you may be asked to find the voltage across all of these 3 loads and the current through ammeter 4. Well, you've got your beautiful drawing here, and you see that this is definitely a parallel circuit. You've got 3 separate pathways, load 1, load 2, load 3. The voltage has not been tested on any of these, but we are assuming that load 1, load 2, and load 3 have the exact same resistance value. And we're given 12 volts here, so we know that you have the same voltage in each branch. The V of the source should be equal to the V1, V2, V3. Every branch is the same. So if it's 12 volts for the battery of the source, then it's 12 volts for V1, 12 volts for V2, 12 volts for V3. All the branches should be identical, but they will share the current. So when you're looking at the current here, the current in this unique path is 3, the current in this path is 2, and the current in this path is 4. Okay, if that's the case, then the total current will have to be the sum of these 3 numbers. So the total current in A4 will be equal to A1 plus A2 plus A3. So 3 plus 2 plus 4, that gives us 9 amps flowing through this part of the circuit here. All right. Finally, I just want to quickly mention combination circuits and some of the things that go along with them. If you have a mixed series and parallel circuit, you have a combination circuit. So here we've got 3 different diagrams that actually show exactly the same thing. In this branch here, load 1 is by itself. So it has equal access to the battery, full voltage. It will share the current, but it's got full voltage. Whereas along this pathway here, we've got 2 lights in this unique portion. And this is going to mean that these guys will share the voltage that's coming from the battery. That's exactly what's happening in this picture as well. Notice that L1, load 1, has its own path, and L2 and 3 are sharing a path. Here, L1 has its own path. Here, L2 and L3 are sharing a path. So all 3 of these diagrams depict the exact same thing. The important thing is can you interpret? So notice that L1 is in parallel to both of these, and these guys are in series to each other, but in parallel to this guy. So here's some of the types of questions that you could be asked. If the voltage across the battery is 9 volts, what is the voltage of load 1, load 2, and load 3, assuming they're all the same? Well, if it's 9 volts here, then it must be 9 volts in this unique pathway as well. And then it'll be 9 volts in this pathway, but shared between the 2 lights. So you would expect this to be 9 volts and this to be 4.5 and 4.5. Exactly the same for the other pictures as well. Doesn't matter which picture you use. What will be the comparative brightness of each bulb? Well, this one, in its unique path, is going to have full brightness because it's 9 volts. These ones have half the voltage, 4.5, 4.5, so these ones will be dimmer. Equally bright compared to each other, but both dimmer than this pathway here, the light bulb in this pathway. Now, we're going to test, and the next question is, if the current flowing through the battery is tested as 3 amps, and the current used by load 1 is 2 amps, what's the current used for load 2 and 3? Well, again, we got 3 amps coming out in this section here, and in anywhere along the shared pathway will be 3 amps. If this pathway is using 2 amps, that means there's only 1 amp left for this entire pathway. So you'll have 3 amps testing along this portion, 2 amps along this portion, and only 1 amp available for this part of the unique pathway right back here. And that's what your answer says down here. And that, my friends, is the end of this lesson.